Before we get all too technical, let's look at a few examples of code objects on this slide. A student object would have his or her name, social security number, midterm, and final exam grades as properties. One of the most important methods relating to student performance in this class could be or would be calc semester grade. A textbook object would have a name / title, author, quantity in stock, and wholesale price. A method to calculate retail price could be set up to calculate retail prices based on the wholesale price and other parameters such as markup that may be specific to a certain location. An event could be raised when inventory falls below a certain level, and the event handler would then presumably be programmed to place an order with the supplier or publisher. We will start building a simple consumer loan class with VB shortly. Some of the basic properties could be amount borrowed, interest rate, and term of the loan. A calc MTH PMT or calculate monthly payment method would have to be programmed to use these properties and return the monthly payment of the loan. Defining a class in Visual Basic, and the syntax is similar with other object-oriented programming languages such as Java and C++, starts with the class keyword, following with the name of the class like car, as shown right here on the slide. Statements defining the various properties of a car, such as color, make, year, weight, etc., follow next. Once all the properties are defined or specified, a set of methods defining various behaviors / actions a car can take, such as drive, turn, park, brake, etc., are defined next. We will skip the events for now, but we'll come back to these shortly. Once the entire class car blueprint is specified, the end class keyword, shown over here, is entered to signify we are done, at least for now, with designing our car class. If another property and or method is discovered as needed at a later date, modification of the class code or class car code should be pretty straightforward. It will not affect any application code that uses our car class that has been written thus far. This makes for a fairly robust and easier to debug code. As we already mentioned several times, an object is just an instance of a class and is created using a regular dim statement as shown at the bottom of this slide. We have already seen in our database programming section a number of examples where an object of a particular class, and here think data adapters and data set, is declared and instantiated with a single dim object name as new class name statement. So to declare Adi as a new object of car class, we simply type dim Adi as new car, open close parentheses. We can separate the declaration and instantiation with dim Adi as car, declaration statement, followed by Adi equals new car, open close parentheses, object instantiation statement. The open close parentheses following car class signify the call to a default constructor, which can be modified as we will see a couple of slides down the road. After an object, Adi, of car class exists, we can do a number of different things with it. We can assign values to its properties, in essence adding data to an object such as Adi.color equals red. We can then use those properties to assign their values to a variable like mph equal Adi.mph and do something with it. We can initiate an action behavior by calling a method like Adi.turn. And finally we can raise events and have objects respond to them. Raised event sold would be handled in a separate procedure, think click event handler, and presumably finalize processing of various paperwork, removing the specific Adi car object from the inventory, etc. Now we go into a little bit more detail on the concepts covered in the last few slides using loan class example, so we can ease into the actual coding. Let's start with the properties. The actual data is stored in so-called private member variables. The convention has them start with a lowercase m followed by an underscore. For example, m underscore amount would be a private member variable of type double. The member variables, unlike with the data structures we had before, cannot be accessed directly from the code. Instead, an indirect access through something called public property blocks facilitates the data exchange. There are two types of public property blocks, one that gets the property value / data and another one that sets them. You can think of these as reading / writing data. A particular property, such as social security number, could be write only, which means it would have a public property block setting or writing its value, but it would not have a public property block getting or reading its value. On the other hand, we could have term as read-only property if we are willing to assume all mortgages are 30 years in length, which they are not. All of the properties we will use in the loan class will be both readable and writable. The property blocks, both for setting and getting values, would in general be used for data validation, perhaps some transformation, and any other manipulation needed to assure data integrity and security. In our examples, we are not going to have much in terms of validation or any other code, but we'll simply allow writing, reading at will, which of course defeats the purpose of data encapsulation, but it makes it simpler for us to get through the material. Class methods, implementing object actions or behaviors, are created with subs and functions, so just like any other user-defined procedure. For example, the function calc mthpay as double would be used to calculate the monthly payment based on the given financial properties discussed on a previous slide. Once the object mortgage of class loan is declared, then instantiated, we would specify all of its properties, such as mortgage.term equals 30, and use its methods such as mortgage.calcmthpay, using the dot notation similar to what we've done with data structures earlier in the class. Okay, at this point, we will open the payment calculator project from the 03 OOP folder in the lectures subfolder. We'll review the FRM payment calculator form and switch to the code. We'll then begin programming the loan class and use it in the main program shortly. I'm actually not going to do that right now. Before I do that, I will go through the two more slides. This slide discusses object constructors as special class methods. They automatically get called as the new object is instantiated. Dim mortgage as new loan, open close parentheses, indicates that the default constructor is called. We could program the default constructor to set some object values using public sub new, open close parentheses, followed by references to class properties initialized to some constants such as term equal 30. A more useful is a constructor shown in the middle of the current slide right here. It passes some values to the new procedure and initializes the mortgage loan to 30 years, 200 grand, amount borrowed, and 4% interest rate. Also, and this is discussed here at the bottom, Visual Studio automatically creates get set procedures when you define the property as public instead of using private member variables. Again, this is not considered a good programming practice, but can be used for expediency, and I will demonstrate both approaches in the payment calculator VB project once I finally start it shortly, or in the next video, I should say. Next, two additional methods returning the remaining balance as of a given date and interest that will be saved as of a given date have already been coded, as you'll see once we open the project, but are currently commented out. Both serve as examples of additional methods beyond the basic monthly payment calculation, and also they will allow me to introduce the date time picker control and demonstrate its use on this particular example. Okay, so this is going to be a good time to pause and then open up the project and start coding.